Okay, this is the Developer Automation and Continuous Integration mini-conf. Session 2. James Blair's going to talk about Zuul.
Hi, I'm James Blair, and I'm going to talk about Zuul. Who here was here for Monty's talk this morning? So, almost all of you. That being the case, I'm going to breeze over some things at the beginning, particularly the slides that are exact duplicates of slides from Monty's talk. This talk is about one of the pieces of software that we use in the OpenStack infrastructure. Monty mentioned it this morning. It's called Zuul, and it's the thing that we use to tie Garrett and Jenkins together. It drives a lot of the automation that we do in the project. Assuming that I finish up a little bit earlier as I skip over things that Monty already covered, I'll fill in some time talking about some of the other things Monty mentioned, like Jenkins Job Builder and anything else that anybody thinks is interesting. So I'm going to cover just a little bit of the development process in here. Maybe flesh out a little bit more about project gating, because that's pretty key to what we're doing. Talk about Zuul, and maybe talk about the Jenkins API a little bit, which Zuul uses pretty heavily to get its work done. Everybody know what OpenStack is? Lots of people have been mentioning it all day long, but hey, it's a open source.
Only vaguely.
Oh, okay.
I know how you develop it pretty well, but
right, yeah, okay. So hey, let's start with that then. So OpenStack is open source software for building public and private clouds. So it's the as Monty mentioned, it's actually a collection of projects that work together to give you a complete cloud infrastructure. So if you need to spin up virtual machines or have globally distributed object storage, federated authentication, all of the kinds of things that you'd need to do cloudy things. OpenStack is open source software to do that. There are a couple of major public cloud providers running this software. Rackspace and HP come to mind. But one of the key things is you can download it, run it yourself inside your own enterprise. So it's great for that whole public-private hybrid cloud thing. So that's OpenStack, and we'll be, I'll use some examples of some of our specific projects in here. And here's a list of, I think these are the current core projects.
Yes.
I think there are 14 here. Monty mentioned 18. That's because we have a couple more in incubation that are sort of. Honestly, the idea is that they're ramping up to sort of join the project, join our infrastructure, the development environment, get coordinated in our release. As we've automated more and more of these systems, that's become easier and easier. So actually our incubated projects already mostly behave like core projects, which is fantastic. There are, how many, Monty? How many contributors?
500 now.
There are 500 active technical contributors working on these projects. A lot of them come from commercial entities, so these are developers who are paid to work full or part-time on this open source project. Some of them are new to open source software development. Some of them are old hats. Some of them are good programmers. Some of them less so. We get all kinds, and a lot of what we're trying to do here is to level the playing field, to make sure that that everybody can get their work done, and people aren't inhibited from doing their work by, say, bad code landing in the tree, things like that. A lot of what we're doing is trying to do things consistently. We're trying to make it so that developers don't waste their time. We're running tests in standardized ways. We're running them automatically for them. We're trying to make it so that as we've added these 500 developers, that they get up to speed pretty quickly and join our workflow. if you were here this morning, you saw this exact slide, but it bears a little bit of repeating. The gated trunk is really key to how we do that. Basically, that means that every change has to be is automatically tested before it lands into the trunk of the repository. So you know that when you update your local copy, when you pull from GitHub or wherever, you know that all of that all of the tests already pass. You can start working on what you're working on, and you have some confidence that if you write some code, run the tests, and they fail, it's probably actually your fault. So that's actually a big thing for developers to always have that confidence, especially for a project this large. So everything that we do is automated. Here's a little screenshot of our Jenkins gating jobs. These are just a few of them, and actually goes on quite a bit. I don't know how many gating jobs we have right now, but in total we have 450 jobs in Jenkins. So there's quite a bit going on here. Though, as Monty pointed out earlier, we don't actually look at this screen much anymore. Most developers interact with Jenkins through Gerrit after feedback on changes is left there, which I'll talk about later. So basically, the process flow for developers is that you write some code, you test it locally, you submit it to Gerrit. Zuul causes tests to run in Jenkins on the code that you just uploaded to Gerrit immediately. So you have feedback as fast as we can get it to you as to whether it passes all the automated tests. Then it goes through peer review. If the core developers on the project like what they see, if two of them approve of that code, they can decide that it's ready to be merged. And then the code is run through tests again, because the state of the repository in the meantime may have moved, probably has actually. So we run it through tests one more time right before we merge it to make sure that it actually still passes tests. And then it's either merged into the repo or not. And assuming it is, then we start doing post-merge jobs like building tarballs, doing coverage analysis, things like that. So Gerrit is a code review system built by Google for the Android project. It's a standalone patch review system heavily based on Git. And it's pretty key to our workflow. Like I said, that's not only do developers upload changes to Gerrit, so that's their entry point into contributing a change to the project, but that's also where all the code review happens, and that's where all the reports from tests that we run, and actually tests that other people run as well, can all be reported back into Gerrit. So it's a big part of a developer's workday when they're doing code reviews or submitting changes to the project. In Gerrit, we basically have a couple of states in the workflow. You submit a change can also, this is actually more of a matrix, but a change can, after a change is submitted to Gerrit for review, we have an indication of whether it's been verified or not by the automated testing systems. We have indications as to whether it's been reviewed and what kinds of review scores it's gotten, how many people have reviewed it. And then, the core developers decide whether to accept it and merge it. So there's a couple of key types of events in Gerrit which Zuul acts on, and these will be important as I sort of explain the different kinds of automation we do in Zuul. So whenever a change is uploaded to Gerrit, that emits an event, and you can actually consume this event over an SSH stream. It just spits out JSON information about the event. And so Zuul watches this in real time, and so as soon as a patch set is uploaded, that's when we start running the check jobs to try to get information back to the developers as quickly as possible about whether the change even might possibly work or not. When a change is merged, that's also emits an event, or when somebody leaves a comment on a change or leaves a vote on a change, that's another event. It's the comment added event. So there's one more too. There's also ref updated. So if you're pushing tags or something like that, we get notification when somebody pushes the tag, and we can trigger off of that. So this is what, this is a section of the page in Garrett. I think I can make this a little bigger. That shows what the feedback looks like, both from users and from Jenkins. These all actually expand more if you want to see comments. You could, you can see that Daniel, actually wrote some comments here, like, that's a good question. I was trying to do this. And so anyway, developers go back and forth on the implementation of a change, that sort of thing. All along, whenever somebody uploads a new patch set, here somebody uploaded patch set 5, and then Jenkins came back and said, yeah, that works. Then they uploaded patch set 6, Jenkins came back and again said that it works. And then we've got links to all of the test outputs so that developers can go and see the logs from running the tests. If something fails, they can try to figure out how what caused the failure, that sort of thing. So we have a couple types of jobs. The check and the gate jobs are basically the same jobs. They're going to run the unit tests. They're going to run integration tests and code style tests and anything else that we've decided that we should start gating on. Hopefully someday they'll run upgrade tests and things like that as well. So those are identical jobs. They're just run in different contexts. When it's run in the context of checking a new change that's uploaded, we don't really care so much about the current state of the repository. We just test it against what the current state of the repository is. When we run it in the gate context, then we're actually we're trying to make sure that when the change lands, we're testing everything in exactly that configuration. So, like as Monty put it before, we're trying to test the ultimate state of the repository before that actually becomes the state of the repository. And like I mentioned, once something lands, we build documentation and upload it. We build tarballs and sometimes, and push things up to PyPy also sometimes. So. What we found is that we started doing this kind of workflow with the Garrett Trigger plugin for Jenkins, which is a great tool that watches that event stream that I mentioned and triggers jobs in Jenkins. And it's a great way to get started in integrating Garrett and Jenkins, and it's actually quite sufficient for projects up to a certain size. What we found is with so many of our projects, and their interdependency on each other in particular, we needed something that could both handle more complex arrangements than the Garrett Trigger plugin, and at the same time was actually easier to use and configure. So we wrote Zuul, which is a general purpose trunk gating system based pretty heavily on Garrett, pretty lightly on Jenkins. You could probably replace the Jenkins bits with something else if you want to. And as Monty mentioned, we're going to be changing the way that we talk to Jenkins, hopefully doing it over Gearman. That actually also opens up the opportunity that Zuul could trigger anything that you could plug into Gearman instead of just Jenkins. So, but another goal of this is to make the configuration of the system easy, especially for however many projects that we have. And finally, we were running up against a scaling limit with the Garrett Trigger plugin. Our integration tests currently take 45 minutes to an hour. And so you can imagine that if what you're trying to do is before every change lands, test it against the current state of the repository. Logically, the most correct way to do that is serially. You have your current state of the repo, you have a change, you apply the change, you test it. If it works, you merge it. then you do the next one, right? If it takes an hour to run our integration tests, we can only merge 24 changes in an hour, in a day, and that's not going to cut it with 500 developers working all the time around the clock. So another thing that we did with Zuul is to give it the ability to test changes in parallel, but still do it just as correctly as if we had done them serially. And the way we do that is with speculative execution. So basically what Zuul does is it builds up a queue in memory of all of the changes that need to be merged. So that queue is a serial data structure. It starts testing all of the changes in that queue in parallel with the assumption that they're all going to succeed and they're all going to merge. And if that's what happens, then that's great. That means you can merge as many changes as you can test in parallel, simultaneously. If a change fails, then it's going to have to figure out what impact that has on the queue and possibly start over testing some of those changes again. So I have a little bit of visualization here about this. It might help explain it a little more. So in this, we've got two projects. We've got Nova and Keystone, and these little dots represent the commits on the head of the repository. You can think of this like the little subway map in GitK or whatever. Here's the head of these two projects, and then say a developer or developers go into Gerrit, do a bunch of code reviews, and say, yeah, these changes are all ready to merge. So what happens is Zuul, as each of those events is emitted by Gerrit, Zuul picks them up and adds them to a queue. So a developer says that this change number 1 for Nova is ready to be merged, and so is this one, and then there's a change for Keystone that needs to be merged, and then a change for Nova. So the reason why these are both enqueued in the same queue is because, again, as Monty mentioned earlier, all of these projects have separate Git repositories, but they're really the same project. They're highly interdependent. And you can break Nova by merging a bad change to Keystone. So our integration testing is key, and so what we do is all of the projects that have this kind of relationship with each other, we make sure that changes to those get enqueued into one queue when it's doing this virtual serialization thing. So once changes hit Zuul's queue, Zuul tells Jenkins to start running test jobs on them. They might take different amounts of time. Some of them might succeed. Some of them might fail. So here we've got we ran the tests for all 4 changes in parallel. It looks like Nova has four test jobs. Keystone has 3. And once they're all finished, Zuul can decide that, okay, yes, this change for Nova passed its tests. It's ready to be merged. This second change for Nova also passed its tests, and it's ready to be merged. This change for Keystone failed one of its tests, and so it can't be merged. That means that it gets kicked out of the queue. Now, this fourth change that was also to Nova, it had been tested with the assumption that everything ahead of it was going to merge. And that was true for the first 2 changes, but that was not true for the third one. Basically, the state of the repository that Zuul had assumed would be the case when this merged is not the case. And so Zuul has to start a new set of tests with the current state of the repository. And this time it works. So presumably that meant that change to Keystone actually was the thing that caused this change to fail earlier. So it's actually okay to merge this change. So in this case, we merged 2 changes simultaneously, essentially. Then we had to go rerun some tests for an extra one. So in the best case, you're looking at being able to simultaneously merge as many changes as you can test in parallel. In the worst case, you're looking at the old serialized system that we had before. where basically Zuul might test a change, it fails, it tries the next one, it fails, and that sort of thing. The reality in practice is somewhere in the middle. We're seeing that on average, when it's really busy, Zuul might merge 10 changes simultaneously, and then there's one that fails, and so it gets kicked out, and Zuul might then test the next 10 in parallel again. So it's a significant increase in throughput over what we could do without it. And the better the code and the better the tests, the faster it runs.
Can you handle the situation where, like in that, if you had the Nova patch number 4 would work, but only if the keystone change went in? You know what I mean?
Right.
Dependent patches.
Yeah, so in Garrett, there's been a long-standing project to add cross-repo dependencies to Garrett natively. That hasn't happened yet. There's a lot of code out there, but particularly with large changes to Garrett itself, they're really conservative about it. So hopefully when Garrett understands that natively, we'll start doing something with it. If we need to do that before then, we could actually, we could teach Zuul how to do that without having Garrett to understand. I mean, of course, we could probably carry this patch ourselves. We're not really, Garrett's written in Java, I should say. So our idea of a fun time isn't writing or maintaining a huge patch to a huge Java program. So Zuul's written in Python, so it would be far easier for us to just teach Zuul to like understand an extra commit message tag or something like that and do what you're talking about.
But can you guys step past the system when you need to? Can you just go, look, I know there's 2 patches, broke your test, but please merge both of them and everything will be fine?
So that oh right, you weren't here this morning. Monty talked about the egalitarian principle that underlies everything that we're doing. We try to make it so that people aren't special, and part of that is that we're pretty strict about these things have to pass tests. We try to, as much as possible, follow that because it puts everybody on an equal footing. That having been said, if we really got into a position where there was some crazy circular dependency and we just needed to move past that, we could do something like that. We could say, okay, well, we'd run the test ourselves, make sure that it worked, and do that. So I mean, it's a nearly slavish following of the machine. If we really need to do that, we could, but that puts us in an uncomfortable position, and we don't want to get into it. So Zuul's configured with a YAML file. We've discovered that we really like YAML because it's easy for us and machines to read, and it lets us start to really quickly define nice data structures. Like we can have a whole series of different pipelines that get nested arbitrarily deep, things like that. So all of the things that we talk about obey YAML configuration files now for this sort of thing. So Zuul has very little idea of our workflow built into it. It's highly generalized. So everything that we do, we've used the basic building blocks that Zuul provides, and we've built pipelines that accommodate our workflow out of them. So the jobs that get run when a patch set is uploaded, that's we define a pipeline. We call it check. Oh, I didn't turn off the thing. We tell Zuul that it's that all of the changes in that pipeline are independent, so it doesn't need to bother doing its virtual serialization thing. It can just test changes and report back as quickly as possible. It should start doing that whenever there's a patch set created event from Garrett, and if a change succeeds, it should vote 1 in the verified code review column in Garrett, and if it fails, it should vote -1. So Garrett lets us define verified code review and then approved. Actually, Garrett lets us define any number of those things. We've defined verified code review and approved as the different code review voting columns in Garrett. So again, none of this is really built into Zuul. I mean, it doesn't know what the word verified means. It's just going to pass that into Garrett. It doesn't know what patch set created event is. It's just going to look for one of those. That actually gives us a lot of flexibility to build up these pipelines. So for the gate pipeline, which is where we're actually trying to merge something, that's very, very similar, except that it's a dependent pipeline, meaning it needs to obey not only changes that depend on each other in Git, but it also obeys the virtual serialization that I mentioned, where a change enters the pipeline. The next one then, for the purposes of Zuul, then depends on that change ahead of it being merged. So in this case, we run these jobs when somebody leaves a comment in Garrett with an approved vote of 1, which is something that only the core developers can do. That's their indication that says they want this change to merge. We tell it that when it starts testing a change, it should clear out the verified column in Garrett, because at this point it'll probably actually have a +1 in there from the check job. So this gets it cleared out so that when people look at the change, they'll see the current state a little bit better, and they'll see that there is currently no vote from Jenkins because the tests are running. And then again, when succeeds, it should vote +2 on verified, which is more than +1. So it's really verified at that point. But that's actually something that's required by the Garrett rules that we've set up. You have to have a +2 verified vote before something can change. So this is almost the actual implementation of the gate itself. It can't merge unless it has a +2 verified, and this is the only way to get it. And then submit is Garrett speak for merge the change. And then, of course, if something fails, then it gets a -2, just to indicate, again, that happened in the gate queue. We can trigger on ref updated events. So that means when a change is merged or a tag is pushed, both of those kinds of things update a ref in Garrett. Obviously, it'll be the master ref if you've just merged a change to master. If you push a tag, it'll be refs, tags, whatever. In this case, what we're doing is we're actually matching branches here, because Garrett doesn't put refs on the beginning of a ref if it's branch for some reason. So this means that whenever we receive a ref update event for a branch, then we run the post jobs. So basically that means every time something is merged, we start running code analysis and documentation builds and things like that. With all these building blocks, we actually discovered a couple more things that we could build without. I was actually going to go add something to Zuul to have a system where we could try out new jobs without having them vote. And then I realized I didn't need to write that as code. I could write that as configuration. So here's a pipeline that runs jobs on patch set created again, but it doesn't actually vote. You'll notice there's no section here for success or failure or anything like that. So this just never reports to Garrett. This just triggers jobs in Jenkins, and we can go back and figure out how those jobs are performing as we develop them, and the developers never see it. Here's another ref updated where we're actually looking for tags. So Monty was talking about the tag-based versioning that we do earlier, and this is how that's implemented. So whenever a tag is pushed to Garrett, we run the publish jobs, which, as you might expect, starts publishing artifacts. So once you've defined all the pipelines, you can set up your projects. Here's the definition for Nova. We actually have a few more jobs than this now, but you can see that since we defined the check pipeline earlier, we say for when a change is uploaded to Nova, these are the jobs that the check pipeline needs to run. First, it checks to see if it can merge, and if that succeeds, then it runs all these other things like the Python unit test, the PEP8 style checks, and the integration test. Like I said, those same jobs also run on the gate pipeline. We don't have to do it this way. We can actually run extra jobs in check to provide feedback to developers that maybe doesn't actually affect the gate. So that's why they're defined twice, even though they're identical here. And then once a change lands to Nova, we build a tarball and we upload docs, except we don't actually build a tarball anymore. The change, earlier when I said that Nova and Keystone in that example share a change queue, that's calculated automatically by Nova. By Zuul. So in this case, we've said that the Nova project runs the Gate Tempest DevStack VM job, and the Glance project does too. So Zuul sees that and says, oh, these projects are running the same jobs, therefore they must be related, and so it starts building change queues out of that automatically. So if you run the Tempest job, your project will automatically be incorporated in this virtual queue that includes all of the OpenStack jobs. We have a lot of other projects in our system, like for instance the OpenStack infra repository, where we keep our Puppet configuration, things like that, that don't need to be in that same queue. And so they actually won't be. So those changes might merge a little bit faster if the main queue is busy. So here's another little bit of a visualization of what Zuul. It's not going to get any better. So this is a screenshot of what the status page looked like on one particularly busy day, where we've got all of the check jobs running over here in parallel. So each of these boxes is a change. Somebody uploaded a change to Keystone, somebody uploaded a change to Swift, to Nova, etc. And Zuul just started running tests on all of these changes in parallel. Over here in the gate queue, somebody was really busy approving changes to be merged. So here somebody approved a change to Tempest, which is our integration test suite. After that, another change to Tempest. Then several more projects. So all of these, as indicated by these little arrows, are in one of those virtually serialized queues that I mentioned. And so if all of these finish tests and they all succeed, then they'll all be merged in simultaneously. And then the other pipelines that we've configured are mentioned are listed over here, but they don't actually have anything running in this example right now. So Zuul uses the Jenkins API to get a lot of its work done. This is sort of if you use Jenkins and you haven't looked at the Jenkins API, it's actually pretty convenient for a lot of things, especially if you have a large project infrastructure that you need to automate. You can get job lists of views. You can read or write the job configuration. You can launch builds, change build descriptions, cancel, all that sort of thing. So also add new nodes. We actually use that a lot. We dynamically add nodes to Jenkins using the API as well. Like I said, Zuul does a lot of things right now using this to integrate with Jenkins. As we develop the Gearman plugin for Jenkins, we'll probably use the Jenkins API less. Obviously, this is over HTTP, so it's got it's a little bit looser. It's not long run connections. You have to do lots of error handling. I think the Gearman work that we're doing will actually make the integration of things that want to run Jenkins jobs a lot nicer and a lot more generalized. So like I said, we do everything in Python. So here's, this is all it takes to start building a job in Jenkins using the Jenkins API from Python. So it's as simple as you would expect it to be. Zuul gets notifications from Jenkins when jobs are finished. Again, also we actually use the notification plugin to do that. So Jenkins makes an HTTP call back to Zuul to tell it whenever a job is finished building. So there's just a little, we have to have a small web server in Zuul right now to handle that. But it's really easy. It just posts to a URL that you configure and sends you some JSON data. So the code for Zuul is in the OpenStack infra org on GitHub here. There's a Launchpad project for it. We host the documentation, which is, of course, built by one of those docs jobs I mentioned earlier. We host some documentation on our site. You can chat with us in OpenStack Infra about any of our tools, and we have a mailing list as well. And these slides are also at that GitHub org. So are there any other questions about Zuul? So we have a few minutes. Oh, hey. So this is actually the real current status page for Zuul. So you can waste lots of time just getting mesmerized by this, or I can. So here it's there's 2 changes that just got uploaded and we're running check jobs on. These are all links to the job. So if you're like, oh hey, look, this Pylint job failed, I want to find out why, you can go ahead and just link straight to the running Jenkins job. Yes.
I'm trying to understand how the how do people submit their patches? You got how do you I mean you're not committing it to the main trunk, right? So you've got some code. What you just generate patches with patch and submit those? And you submit the code?
So we try again. So here's what our Garrett looks like. So somebody has uploaded this change, which is 20573, which is this one over here in the Zuul status queue. So once it's uploaded, this is what it looks like. It's obviously brand new, so it doesn't actually have any review comments yet on it or anything. But you don't use the web interface to upload the changes. In fact, we wrote a program called Git Review, which acts as a Git subcommand. And what it does is pushes any outstanding changes in your local branch up to Garrett. So basically the developer workflow is you write a change, you git commit it, and then you type git space review, and it does everything automatically to push those changes up to Garrett. So it's actually, I really like it. It makes submitting a change way easier than formatting a patch, mailing it, anything like that. It's just a single command, and it's off your plate. You can move on to the next thing.
So you've committed the code to your local. You've cloned the Git repository. You've changed the code. You've committed it to your local Git repository, and then you Git review.
Yep. And then that's it. It just so the way it works is it compares the whatever. It's basically a push to it's a git push to a specific ref in Garrett, and I mean if you dig all the way down to it, it's not much more than git push Garrett refs. Or head : refs for master, and what that does is it pushes any outstanding changes in your branch to that special ref in Garrett. And since it says refs for master, Garrett says, this is a change or series of changes. Actually, it can push up a whole series at once that are intended for the master branch, and they just show up automatically here.
Yeah, so it under the covers basically magically creates branches on, not actual branches, but it creates magical places for you to put them in Garrett, so that you don't have, so that you're not having to push to a privileged place. It's refs for master is like a magical,
right?
It's like a magical ref. It's not a real ref on the because
Yeah, you can't go fetch something from refs for master. It's just it's sort of a little Dropbox kind of place, and then what it does is it creates a change record in its database. So it assigned it a change number 20,573, and then it does put that change in a ref that you can get. So it actually does. It doesn't like store the Git commit in a private database or anything like that. It sticks it in the actual Git repo, but it sticks it in there based on its change number. So what you can now do is you can run this command here, git fetch the URL, refs changes 73 is just a hash, 20573/1 is patch set 1, and anybody can download this change. Of course, that's actually what Zuul is going to do. It's going to fetch this change, merge it, start running tests on it.
I mean, that's an interesting problem too. It's a very good thing to review code before you commit it, but you've somehow got to be safe about how you separate the
Exactly.
code, and I'm just trying to understand how.
Yeah. So that's all completely unprivileged. Anybody in some Gerrit installations, anybody with an account, which you can just get for. All you have to do is register and upload an SSH key, and then you can upload changes. In ours, you have to agree to our contributor license agreement. Once you've done that, then you can anybody can upload a change. But it doesn't get merged until obviously all of that review happens. On the right or left, house left.
Can you set up the Git review? Does it copy the comment book?
Yes, that is one of the things that it does. So you mean the Gerrit commit hook? Yeah. So Gerrit has this. I had this. Gerrit is in the middle of a long, long transition to from these numeric IDs to SHAs for their change IDs because why wouldn't you want this to identify your change, right? But at any rate, that's one of the mechanisms Gerrit uses to detect if you're uploading a revised version of a patch set. If the change ID in the commit message is a change ID that it already knows about, then it says, oh, you're pushing up patch set 2 of this change. And so it does that instead of creating a new change. There's a commit hook that Gerrit supplies that will write this change ID for you automatically as soon as you commit something. And so Git review, in addition to pushing changes up easy, also tries to automate the initial setup of your repository. So it'll copy that Git hook into place. It'll set up a Gerrit remote with your username and everything like that. We put a Git review, a .git review file at the top of our repos with the URL of the Gerrit server. So you don't even have to configure that. Like literally just clone from GitHub and type git review, and it'll do all of the configuration itself. It knows where to send changes.
So your commit should happen only after you set up the Git review. Otherwise, your commits wouldn't have the change ID, and you would have to.
Git review detects if there's something been committed without a change ID, and it does a rebase or an amend or something. To cause that to have a change ID added before it gets uploaded. So yeah, in fact, we wanted to handle that case too. It's just supposed to work without having to think about it. So, and in the back.
What is the gears thing you said? Is it going to replace Jenkins?
Oh, the Gearman?
Future thing?
Gearman, is that?
Gearman,
Yeah. So it's not going to replace Jenkins. It's going to replace how we talk to Jenkins. Gearman is a general job queuing and management system. It was written by the journal guys originally. It's the idea is, hey, you've got a bunch of servers that all can run some job. So if you're live journal, it's probably like scaling an image or something like that. And so if you need an image scaled, you submit a job to Gearman saying, hey, I need this image scaled. Gearman knows all of the machines that can run that job, and it dispatches it to one of them, and then reports the results back, which of course is exactly what we need with Jenkins. Jenkins, has lots of slaves that can run jobs for us, and we need to get jobs dispatched to those slaves and then have their results reported back. So that kind of integration with Gearman makes a lot of sense. But then that also generalizes it so that we can have more than one Jenkins master. Right now, Jenkins, I'm going to put an asterisk here and say it doesn't really make sense in most situations to have more than one Jenkins master. There's no real multi-master federation that you'd like at that level, and so Gearman will let us have multiple Jenkins masters, and it'll let us trigger on jobs on things that aren't Jenkins. We don't have any immediate plans for that, but once we've separated the thing that decides what to run, which is Zuul, from the thing that runs things, which could be Jenkins or could be something else, and we use Gearman as the integration point. We could dispatch to anything that we could have Salt run things on Salt nodes, or whatever you want to do. So I think it'll be a really. We're trying to make that generalized too. So it'll be great for what we're doing with Zuul, but it'll also be hopefully generally useful to the Jenkins community.
Great, we've run out of time, so thanks very much.